G'day everyone, video today for methods year 12 is on the quotient rule. Now there's three major rules. Once you've got past your differentiation or your basic differentiation, your individual terms differentiation, and the limiting sum or the limiting chord idea, which is your differentiation by first principles. Once you've got past that, the thing you want to concentrate on is your three rules: your product rule, your quotient rule, and your chain rule. This one today is about the quotient rule, and quotient, if you're not sure, is when you're talking about dividing one thing by another. Okay? So whenever you divide one thing by another, you're talking about a quotient. Okay? Hence the quotient rule. So if we have something set up like this, and look at my example just here to give you a bit of an idea of what I mean. You're going to have two functions, one on the top line, one on the bottom line. Because they are functions, they're both going to have an x term in there somewhere. Okay? So if this was just 3 divided by x, that's a different sort of question. Okay? If this was 4x divided by 5, that's a different sort of question. That's really just your standard question. It's when you've got an x on the top and the bottom line, that's when you want to use the quotient rule. Now don't jump to the quotient rule straight away, because sometimes you may find, not in this case, but you may find you can do a little bit of simplification here, and then you don't need to use the quotient rule. So if you don't need to jump to it, you might want to say, well, look, you know what, I'll see if I can rearrange first and then take the derivative, and that's okay. It would also be okay to go, I'm not even going to look to rearrange, I'm just going to use the quotient rule straight up. That's fine. So if we have this format here, then this is going to be the derivative of it. Okay? Now, the little dashes, remember that's the derivative, so u dash means the derivative of the top line, okay? And v dash means the derivative of the bottom line. Now this can be written in at least 3 different ways, because remember we've got different notation. We can use u dash, we could use du dx, the derivative of u with respect to x, and we could also, if this was written in f of x over g of x format, we could rewrite it in a different format again. So be aware there's a number of different formats here based on the different notation, but they all say the same thing. So I think the easiest way to get a grip of this is actually do an example here. Now I would suggest in the first couple, write out something like this. Okay? Now you might say, oh, that's pretty easy, I can see where I'm going, and you're right, but it's handy to do this in the first couple so you've got it. So u is the top line, so I'm working with 3x plus 4, or 3x squared plus 4, and the derivative of that is going to be 6x. Similarly, v is the bottom line, so I've got x plus 1, and then the derivative of that is just going to be 1, because remember the 1 here disappears. This is really x to the power of 1, power out front, lower the power by 1, would become x to the power of 0, x to the power of 0 is equal to 1. So we've got all the information I need here. Now it's going to be a lot easier to use this and just slot the things in. So it's v, so it's x plus 1, getting that from here, times u dash, minus u, so I'm up here, 3x squared plus 4, times v dash, which is 1, all over v squared, here's v, x plus 1 squared. Now you could leave it like that. You could leave it like that, and you wouldn't be wrong, because if the question said differentiate, that's the differentiated version. Most of the time, although not always, we'll say differentiate and simplify. So then we just look and see if we can tidy up mainly the top line, and I think we can just a little bit. We'll get 6x squared out of here, plus 6x. And out of here, because this is times by 1, I really need to only multiply in the negative 1 here. So it'll be minus 3x squared minus 4, all over x plus 1 squared. I wouldn't multiply the bottom line out. I think x plus 1 all squared is neater than x squared plus 2x plus 1. I wouldn't multiply the bottom line out, but I would the top line, because I've got separate terms that I'm going to be able to bring together neater. 6x squared minus 3x squared is going to leave me with just 3x squared, plus 6x minus 4, all over x plus 1 squared. And that's where I'd leave it.
So you don't have to do any more than that?
No, I wouldn't do any more than that, because the only thing I could do would be to expand out the bottom line, and I'm actually making more terms, not less. You could also do a few other things, but you're only going to make it more complicated. That's where I'd leave it. I wouldn't change anything from there. Hope this has helped to explain how to apply the quotient rule. I am going to look up and figure out how to prove the quotient rule, and then I'll do a video on that one as well so that you've seen it. But if you know this and you can apply it, you're going to be all good. Thanks guys, catch you later.